Okay, good morning. So today we will make some configuration, which is a PAP password authentication protocol in OSPF version 2. So first of all, we need to insert the address of all devices in our topology. For example, here I'm use .10 for PC and .1 as a default gateway for PC 0, and then we use the same address .10 192.168.30.1 for PC 2, and then for the last PC we use 68.100.224 52. Sorry, 224 is a network address, so we need to use another address for PC1. So in here we use a 225, and so we use 226, and then the default gateway is 25. Okay, so next we are setting an address for the router. First of all, we need to change the host name of each router. Here I'm naming it as a router 1, and then insert an IP address of gigabit interface. Actually, the address is need or must be same with the default gateway address for the PC. This situation we use to 10.1, same as the address in the PC, the default gateway address in PC 0. Then serial interface, so that 10.1.1.1. Here it is have a clock rate, so we clock rate 64000 and no sharp. Then we do the same configuration in router 2 level, config terminal, host name, then the interface of 0000, then .1.1.2. .1 we use in router 1 and no sharp. Then for another serial interface 001, then .2.2.1, .252 for prefix 30, and then clock rate no sharp. For it also we need to configure the gigabit internet. So in here use 209.165, 200 and 225, which is the first address for the network portion 209.165.200.224. Which is 224 is used for the network address, and we insert the subnet mask. Sorry. No shut. By default it's shut down, so we are using the no shutdown to active or to enable the connection. between one point to another. So in here, this is the difference between the local connection, which is gigabit or fast internet. We only need to active or enable in one interface only, but the serial interface we need to active or no shutdown configuration in both sides, in the router 2 and the router 3. So in here we change firstly the host name, and then we insert the address for serial 000 10.2.2.2 255.252, and then this is no code rate, so no shut. We proceed with the another interface, which is gigabit interface address 192.168.30.1, no shut. Okay, so as we know that if the network have more than the two router, usually 2, 3 or more, so we need to add with router routing protocol. So in here we have RIP static route, RIP routing information protocol. We also have the ERGRP, OSPF, and so on. But in this situation, we only use we choose that with the OSPF version 2 as a routing protocol. So here is the configuration of router OSPF 10 is the ID. So process ID. So in here we need to have a same process ID in order to make all the network connected between each other. So we also have a network. In here we need to set up the network which is directly connected to the router 1. So how can we know that is directly connected or no? First we know that the connected with the router 0 is two connection, which is the GI00 and the SE000 for the network XE1 10.1.1.0 and 192.168.10.1. Or the second way, we can use this command, show IP route connected. So it will display the connected address for that connected to the router 1. So in here we know directly 10.1.1.0 with the subnet mask, the webcam mask and area 0. So the same 2.5, and then insert 192.168.10.0. So you need to understand about the webcam mask. This is it need to minus between the full bit 255.255.255.255 or the prefix 32 bit will minus with the current subnet mask or current prefix, which is /24. So in here we get the 0.0.0.255, and here we have the 0.0.0.3. This we name it as a webcam mask. So do the same thing into another router to show IP route connected. Router OSPF 10 network 10.1.1.0 webcam mask 3 area 0 network 10.2.2.0 0.0.0.0 3 equal 209.168.200.224 0.0.0.3 area. Okay, that's all for the router 2, and we configure same concept in the router 3. To show IP not created, SPF 10 port 10.2.2.0.0.0.3 area 0 port 192.168.30.0.0.0. That's all for the router SPF. So now we check the configuration. Either it can connect between PC and other PC using the ping command. Okay, so in here we try to ping PC2, which is ping 268.30.1. Okay, so it able to ping the default gateway of PC3, PC2, and then ping the PC. So it will able to ping the PCs. Or you can use another tools here to check either the connection is success or not. Success, and here is success. Okay, so our SPF is done correctly, and each of the PC also can connect with each other. So now we are trying to implement the PAP, or we call it as a password authentication protocol between the serial connection. First of all, the PAP is used to make a security implementation in our serial connection to prevent an attack between router and router to another router. So it prevent the interruption. But the disadvantage of PAP is the information such as username and password will transfer in the clear text or in the plain text. So if the cyber attacker use the filtering application such as Wireshark and so on, so it's easy to get or to crack the information of username and password between the serial connection router. So here this is a example. Okay, so the PAP authentication will configure between the router 1 and router 2. Router 1 and router 2. Yes, router 1 and router 2. So in the router 1, we need to assign the address, username R. This is R2. So the username we need to same with the host name of our neighbor. Here username R2, and the password is Cisco. So we set up the password with the neighbor password in our router. So this password will store in the router 1 database. Zero for the serial connection, PPP authentication PAP. Serial 000 encapsulation PPP. After that, we set up with PPP authentication PAP. By default, the encapsulation protocol is SDLC. So we use the PPP or we use the CHAP. If you use the PAP or CHAP, we need to change the SDLC encapsulation into the encapsulation PPP with this command in the serial connection. So PAP PPP Authentication PAP, and we proceed with PPP PAP, and when send our username and password to the network. That's all. So this information will send to our neighbor, which is router 2, and the router 2 also will send the same information, which is a router 2 password Cisco, to the router 1. Then if the router 1 check the username and password need to be same with the information that used to store in their database. If the same, so the connection will establish and the data will able to send between the two hosts. So now if you are trying to check the connection between the PC 0 and PC 1, I will try to make some ping connection between the PC 0 to PC 1. So it failed because the information of router 2 not sent in a router 1. So this is for the security purpose, the both side of router, which is router 1 and router 2, need to send the same password, and username is follow the host name of each router. So you try to ping that. So destination is host is unreachable. So now we are trying to configure the router 2 with the chat authentication. First of all, serial 000 encapsulation PPP. We active the encapsulation because by default the serial collection of 1 using the HDLC concept. So in here we put the username R1, so this is information stored in the router 2. So the password of a R2 neighbor need to save with this information in order to allow the communication. Then send username R3 R2. So that's all. So we look here that the interface or the connection is changed to up, from the loading to full or to forwarding process. So now we try to check again the connection using the ping command. So we ping the router to default gateway, so it able to communicate. 6 also able to communicate, and then we ping from the PC 1 to the PC 0 using the address of PC 0, so it also able to communicate. So that's all. The connection with serial between router 1 and router 2 using the PAP authentication protocol, and then the side is normal, which is not use anything authentication process. So that's all. for today. So the next slide, I will try to explore about I would like to show about the chat authentication protocol. That's all. Thank you for watching. Don't forget to subscribe.